All right, let's see. So, here we go again. So we're continuing a project that we've been, I don't remember if it was the last one or the one before last, where we were working on a RPC aggregator hub. So using this RPC system, we can basically connect to a hub, publish what methods we have, and it'll relay messages to the proper backend. Specific to this particular protocol, which is one that I've had, I'm going to be rewriting it, but until then I need this for some prototyping. And remember, you can subscribe to this stream as well as see future stuff and find and get a reminder for future ones. I try and put the descriptions for the week ahead and the dates at least for the following week, so they're TBD. If you happen to be watching on YouTube after the fact, leave a comment and let me know what you think of these streams, what I can do to improve them for YouTube. I highly recommend watching them at 2x speed. I was thinking of maybe publishing them at 2x speed, so by default they're played faster. Let me test this chat. I also stream other things, game development stuff, so earlier in the day. Here's all those events. Alright, I think I closed the window that I was using before. You can follow along in this repository. I don't often push, and actually maybe I'll push now. It'd be a good time to do that. Yep, nope, I don't want those node modules. There we go. I'll worry about that one later. This is no production repository. That's sort of the point. Oh, it's still working. But actually, the repository that I was working in for this is Duplex. This is a couple years old. I'm going to be kind of rebuilding this. Smearty, thanks for following. Rebuilding this stack pretty quickly. And I don't know at what point, but hey, welcome. I think I actually started this years ago, even before this repository, but it's sort of like a everyman's gRPC, but the things that it has that are specific to my uses are things with callbacks and persistent connections and stuff like that, and certain things with the API and how it's designed at that level. I've been using it for prototypes for a while in a couple of languages. I have a couple of implementations. I actually remember some of my earliest live coding experiments when I was putting stuff on Vimeo, I think was building this stuff. So when I did the Python, actually it looks like all of them I did and posted those. They were like hour-long sessions with, maybe they were time lapses, I don't know. Early experiments in this sort of thing that was not live streaming, but Smarity, tell me about yourself. What brings you here? Let's see, I need to get the right project up now. This is the right project. Right, I can use these two tabs. So where we got to before, let's see. So the first thing we did last time has been research mode. I also randomly following Twitter. Well, feel free to ask any questions about anything, Golang or otherwise. Otherwise, thanks for hanging out. So last time we built a client and server just to make sure that everything's kind of working with the library. We did an echo thing and then a client. Then we started this hub, and this is the hub where basically things a backend can connect to provide methods as well as call methods. But the backend connects, and I think this client was just to test it. So the idea was we run the hub, we run a couple backends, and then we run a client and see which backend serves it and make sure the right backend serves it. Client, we don't really need front end, it's client for now. It basically, though, made us kind of have to rewrite the API a little bit, kind of re-implement things, which is really helpful for when I go back and rewrite duplex, because then I know better how to abstract it. At the end of the day, a duplex connection is just a stream with, in this case, let's see, are we using message pack or JSON? JSON, so it's just a stream of frames, and each frame is a JSON object in a particular, with a particular struct for a message, which has some metadata, and then there's the payload, which is often the arguments for a method. It's not much more complex than JSON RPC, but we'll kind of get into that more later. For now, what we have is a hub, and instead of sort of like taking messages and then dispatching them to a method, we just relay them to the proper backend. So we implement a method. I think, yeah, we implemented it here. We're using the old API to do this before, but since we're kind of rewriting a lot of the API, we're kind of just like re-implementing it here. So the hub has one method, which is register, which basically right now takes a string of methods that you provide as a backend. And so then we set up a route table that says whatever that method is, it points to this connection. then whenever we get any messages, this is what we did last time. We basically look up the method in the message, get the backend, and then send the message to the backend. And of course, this is because method is included in both the request and the response. What happened was our client would send the request to run a method. It would send it to the backend. The backend would reply, and the hub would get that and basically send it back to the backend. Because we basically have to do kind of like a NAT routing thing, where when a message comes in from a client, we need to remember that client, we need to associate that message ID. We need to rewrite the message ID and associate that ID with that connection, so that when we pass the message to the back end and it responds, it's going to have an ID that we can use to look up which client to send it to. So we kind of have to do like this ID rewriting and have like an ID rewrite table. And so that's what we're going to do next. It shouldn't take that long, actually. So before we were assuming we had a route table of just methods. Maybe we'll call this the backend table. And then a front end table, which associates an ID, which I believe is an int. So the ID is I believe set by the client. Let me make sure of that. Channel ID. When we make a channel, where do we make a channel? Peer and then channel. ID 0. Let's see, let's look at call, open. There we go. Yeah, so the client is actually coming up with the ID, and then the backend kind of just typically would associate that ID with a particular connection. And since we have a bunch of connections, we need to basically remember what that ID was and the connection. Let's see, can we? No. We could hash no, because we need to look up by. So yeah, we need to create a new ID. And it'll point to the hub connection. Again, normally we worry about locking here, but for now we're gonna see if we can get away with not not doing that. Let's see. Normally this would, I mean, at some point we'll probably wrap this up in a struct and just call it like the state of the hub state, right? But we actually need to remember the ID of the message that came in as well, so. We're probably gonna need to do some kind of mutex on here, but just trying to think of how to store the thing. Do it to have maybe a struct that has the connection and the ID. Call it a client or a front end channel. The front end channel. We'd actually maybe embed the connection and then add this ID. We'll see how this goes. Yeah, so at this point we have the message. So instead we'll actually probably want to do something different depending on whether it's depending on its type. Because if it's a request, that's when we want to do something and set up a record for the front end stuff. Duplex. Let's see if there's a type. Yeah. We could do a switch, I guess. It's not that big of a deal. I'm already forgetting because I'm in C# all day. I'm trying to remember if Go needs breaks. It does not. Good. Yeah, because like anyway. So we'll also create a case for the oh, that's the request. And anything else, we'll kind of just say like message type not supported. This is a prototype, so we can just panic on all errors. Okay, so if it's a request, we actually want to check to see. Probably gonna have to do a lock here too. Because it's going to be accessed a lot more than the back end. And like I said, we'd wrap that up in a struct or whatever, but all right. Request comes in. We want to check to see, first of all, I guess we'll acquire the lock. table. Let's see. No, at this point, I was just thinking now too that because every call is actually creates a channel, which is basically treating this like a multiplex stream. It'd be interesting to put the channel construct just at the frame level. Then I mean, there actually aren't too many really. HTTP2 and SSH are the only protocols that really implement like do multiplexing. I think people have done one-off stuff like HashiCorp has one, ngrok. Alan has written one based on a subset of HTTP2. HTTP2 is just too like heavyweight. This is something that should just be able to go over a WebSocket. So it seems silly to implement HTTP2 over WebSocket. So, you know, the simplest thing for and we can kind of do this in a layered way, in the same way that people would do 0MQ things, where you keep prepending message parts and just kind of unwrap it. That's kind of an interesting approach. So that's something that I'll think about when rewriting duplex, but in the meantime, and that'll be fun because we would get to look at SSH and how they do it, and look at HTTP2, how they do it, and just kind of like do the simplest of those. And then we could have kind of a generic multiplexing library for any framed protocol. And actually that would be really useful if the system had that, because then you could reference streams that weren't HTTP or that weren't RPC, so you could actually multiplex other stuff through this. Anyway, thinking too much. Let's see here. So right now I'm thinking, common case, you send a single request. There are the cases where you stream more request stuff. The problem is, let's see, we're associating it with this connection. So you'd actually need something to map incoming IDs. Message comes in with its own client-specific ID, and we need to see if that ID, which we need to think of them as channels, we need to see if that channel, we know if that channel exists, because then we can look that up. So that would be maybe a connection specific lookup table. Let's see, that would, I suppose, give us the new ID that we would have, that we would use here. Because when the reply comes back, so basically we have a lookup in both directions. But it's because, but the reply, could kind of go anywhere, which is why we need to have a pointer to the connection as well, and the ID to write it back to. Call this the original ID. Let's see. Let's make this a little bit more clear. We could actually store this object in both tables. Channel, we'll just call this a channel. Okay, so we also need to make something here. For these lookups, this is, I guess we can just call it channels. And this looks up the local ID to a channel. All right, so request comes in. We look up by ID here. This is, we'll call it exists. If it doesn't exist, we will create a new channel. Let's see, our front end is this connection. Original ID, wait, a message ID. We make it, and then we need to make a new ID. Which we use ID counter. Not sure we can do that. There's no incrementer in Go. That's the other thing. Now we have to do the lookup for the back end, right? This is interesting. I'm kind of breaking down this object protocol. I'm thinking I can create a layer for this. A layer for this metadata. It's just very it's almost recreating 0MQ. Remember the 0MQ protocol was interesting. ZMTP, because it's just very simple. The only complexity seemed like came from it having, well, I mean, it had its types, but in terms of the frame, let's see, more frames to follow. So I wonder if these were frames. Right, 0MQ messages can be multiple frames. It is kind of complicated because you could also, I guess that's what they would call part. All right, so whether there's more and then whether it's long, a value indicating interesting. So this is kind of like a header bit mask control flag thing. Then they have the length, which depending on whether it's long, and you know how to read that, and then you use the next bit to read the next bit on the next part of the stream, and that's it. Like that's their framing protocol. I'm thinking, and so we assume that we have frames. And so then it's just a matter of which channel does this belong to. So then you can have kind of a, I forget what types of messages there'd be, but I mean, you could just have a, you know, let's see, 1 byte would mean you could only have 255 channels open at a time. I mean, we would look at some of these other ones and how they, what data types they use, but length, and then first byte, and then you could have the length of the header. Let's see. The only dynamic thing that isn't the rest of the message is the header. And you could just pull the rest of the message and say that's the body. Yeah, thinking ahead too much. So back here, we need to look up the back end. Kind of like that. So now we have a channel. Oh, we want to put this in various places. So we would put this in the front end table. Kind of make this more clear by doing that. And then we have our local channels. Right. All right, so now either way, we should have the channel. So we didn't have the channel before, now we created it and registered it, and so what do we do with the channel? Basically, we get the back end. Let's see, this is a request coming in, so we get the back end and we send the message. All right, we'll do this. I think we can get rid of all this. So then replies would come back. They're a little bit simpler. We'd also need to lock and unlock this, but in this case, though, if it doesn't exist, then we just kind of like, we would throw it away. So I think at this point we just do this. Oh, we need to say channel front end. Wait, where's our channel? CH. Is it confused because I'm... Right, same down here. I need to say channel backend. And that should do it. So then we need to delete stuff. We don't really delete anything in the backend table. We could delete stuff. I guess we should delete stuff from both channels and the front end table. So we don't care about this once there are no more requests. So we can check the message to see if there's anything more on this channel. That's actually an interesting thing to include at the channel level. As if there's another way to think of it is close. Like, are we done with this? But since you're sending it with a message, it's a little more efficient to say more. So if there's no more, then I guess we can do this while we're inside the lock, even though we probably want to do it after we send the message. But channels. We wouldn't want to delete from the front end table until we've gotten all the reply. So we would do something similar up here. That should be it. So let's try running the hub, and we'll run which one of these? Oops. I guess I'll run this one. Okay, so we've registered some methods. We should be able to run this client. Call register. Oh, I think I meant to actually delete that front end. Oh well. This is our client. We're gonna try and call 2. And I think all of these are just echoing. Yeah. So we'll pass it some stuff. Okay, that's no good. Channel ID not found. So the message got to us, got to our backend. We ran and then we responded. So we send a reply to the hub. when the request came in, it should have made a front-end table. Oh, I think the problem is we didn't update the message. We didn't actually update the ID to be the new ID. So that's probably what's going on here. So when we send stuff to the back end, we're gonna set the ID to channels new ID. Similarly, we should, when we send it back to the front end, we need to set the ID to the channel's original ID. This is the actual rewriting of the ID. Just forgot about that. Okay, so we'll run the hub, we'll run this backend, we'll run the client. All right, well, we upset this one. I don't know why. Close of closed channel. Send what? Send message. Backend 51. Yeah, I don't know where this EOF came from. It might have been this because we closed it afterwards. All right, so we stopped everything. Now we run this. Now we run this. This is still going, and then we can run this. Nope. All right. Well, let's see what's going on here. Hub 62. I mean, in theory, you gotta hang up as well, so maybe we don't want to panic. So, and the problem here was just that it was closed, yeah. So, I don't know what the, I'm guessing it'll be like EOF or something, right? Maybe we can do this. Just say if error equals, then we're done, right? Or rather, we would break. I mean, we're in a function, so we could return. There's nothing afterwards that we need to do. Oops. All right, still a problem. I guess we should just see what's going on here. Error was the error. Unexpected EOF. I don't know, man. I feel like who closed first, I guess, right? abnormal closure. It's WebSocket, so it's picky that you didn't close, I guess. I'm just not sure who actually closed it, because both kind of make it seem like the other one did. Let's try this though. And just see if anybody is happier. Because our back end is, you know, not really do anything weird. So hopefully all right, let's go. Nope. All right, we're all just panicking. If we don't panic, let's say I don't panic, and we just, you know, it's switching between contexts. Let's say we just do that. So this one can't complain that the connection is gone. Sure, then what? What's the problem? 69? 69 of hub, really? Oh, because message is nil. Well, yeah, then we can break, I guess. I mean, or return. So either way, we return. Let me just do that. Close of closed channel. Curious what might be giving this. So not wrapping anything. Send on closed channel. So just kind of curious here. What exactly would be trying to close? Well, I'm a little bothered because I'm looking at this. That doesn't seem to be the right line. That's very interesting. This is my back end. So, is something not getting set up here? What's interesting, though, is let's see, we called to. I don't know, I'm just so. Confused by this. So the other, let's see, possibility. Why would it close the back end? This is this. We look up the back end here. Back end. And we set it up. And those back ends come from when we registered. There might be some thinking about this a little bit wrong. Request comes. In the case of the other one, our connection is just sitting there. If we were to send the reply, look up the front end table based on that ID. Send to the front end. So before it finishes before it can say it responded, some state somewhere. Thing is, I don't actually think it's on this end that's causing the problem. I think it's the hub. I mean, we could try some like high precision logging to see which one happens first, but and this might be totally misleading. Like the hub could have done something wrong that caused the backend to do this, which then causes this unexpected EOF, right? Because it disconnects. So that actually might be it. This could be a red herring. I think it has something to do with how the hub handles these back-end connections. So I connect. This is kind of if I make any client connections, but the backend won't. Then we sit in a loop and we receive messages. We receive a message method for register, and we load it in there. Back into the method, send back our reply. we always get that far. That's this reply. So then our hub doesn't hear from that back end. Let's make sure that there's not any like it continues, so it's basically skipping anything else here, which is good. And then on the it's on the hub side, talking to the back end. So then the hub side talking to the front end. It gets a message, it's a request, so tries to look it up. It doesn't exist, so we look up a backend for this method, and sure enough, we have one. So we create a channel referencing this front-end connection and the back-end connection that we just found. We mark the original ID, and then we generate a new ID from the current state of the counter. We put this channel in these two tables, front-end table based on the new ID, and channels based on the original ID, both pointing to this. Increment the counter. At this point, if the message says there's no more to it, then we delete this channel on this side, because we're not going to be getting any more messages that need to look up where to send them. So, and really, even if this did the wrong thing, we'd just create a new channel. So we unlock, set the ID to the new ID, and then this back end, we send the message. And we get that on the back end, gets the message and even triggers what it's supposed to do. But for some reason, in the next moment, some connection breaks down. I'm trying to think, it might have to do with me setting the ID to some other crazy thing. I don't think Duplex cares what the ID is when it comes in. So what do we pull in messages for? It'd be a send. Well, let's just see what send is doing. Send. Doing a code and a write. Oh, well, that's interesting, right? Did it? Oh, that's funny. I didn't, for some reason, skipped this. Why did I do that? I just assumed that it couldn't have been in Duplex. If ID is 0. Oh, I forgot. This is happening because actually, let's do it like this. Because of this incrementer, it's not used to this idea of using 0 because when I wrote the protocol, I didn't make the ID a pointer, the ID in the struct a pointer, and so you can't have a null value. So 0 would be a null value, so we can't use 0. So we have to increment it before so that we start with 1. This should work better. But we'll see. Okay, we responded. Everyone seems happy except the client. Who knows what the hub's doing? But it seems as though the client's not getting what it needs, which, we're not doing anything special. We'll take any value and then print it out. So I feel like we're not doing this properly now. Let's see here. We could just print out all these messages, right? Kind of see a little what's going on here. And these are the same so far, so even if this was done wrong, it seems like it should work. So I guess what's interesting is that it's not, doesn't seem to be sending that message. Let's see, send message. Oh, because we're not setting false more. That's probably more, so there's no more. So it should know, or we should know to stop listening for stuff, but send to the front end. I mean, it would be kind of nice if our front end set anything. Is there anything else to learn about this? Method. That's 2. That's the payload. Errors nil. ID is 1. No more. I mean, we could run this against a server that we know should work. Interesting. Interesting. This was working before. Is there anything different with this? Right, server. Echo. Well, apparently, since we wrote this client and server, we've done something to duplex to make it not work. So maybe we can like how do we know what we've done? We refactored a lot of this, sure. Do we need to manually route? I think. I guess is the difference that we changed. Backend client. Yeah, I think that's it. Go peer route. So that's this client. Basically need to do that. And all of these to make them work. Okay, now let's go back to our hub example. And then here we'll go back to our backend, go run. Backend 1.2, we're creating two methods called 1.2, they're registered. And then our client for the hub is gonna look for 2. Okay. I guess we're not properly closing these. I wonder what we can do about that here. When we send a message and it's the last message, right connection. Well, because it's a channel, you don't actually want to close. Let's see, I guess it's our client that we're not closing properly, right? Pure close should do it though. I guess we can make sure and like close here. But it doesn't seem to care. So let's see, our peer, what is our peer doing? Peer. Actually, there's probably a problem with our wrapper because we're using Gorilla. How do you spell Gorilla? Why was I thinking it was anything else? The normal close probably does like a bad close. There might be a different close method that we should be using without sending or waiting for a close message. So I guess though, how do you, I see how we can handle close messages, but how do we actually write a proper close message then? Like, where do we use these? Those don't seem to be used anywhere. Or expected anywhere. I guess send message maybe? Write message. Helper method for getting a writer. Message type. Format close message. Fucking normal closure. All right. So would we, and how do you use this? Do you send this to write message, or do you write this directly? It seems unclear. Okay. Yeah, I can do this. So that's part of our wrapper that we're gonna make here. Cool. And we should be doing that everywhere that we have this wrapper. So this should do it for our hub example. So here I actually test to see if it goes to the right one. So we have 1, 2, methods 1 and 2, and methods foo and bar that are available. And our client First we'll do 2. I can make this, do that again. Okay, everybody's happy. We got a normal close. That seems reasonable. So then if we change this to foo, we should get the message there. And we did. So I'd say this is working. It's still relatively simple. It's just like our details have, because of these abstractions, it's kind of a mess and evolving the stuff along. So I mean, the next step is figuring out how to package this up. Because the next project would basically be using this hub. But there's also not a lot here. We could just kind of, again, because it's for a prototype, and we'll eventually rewrite the RPC stuff, that we can probably just use this code when we do that. But I'm getting antsy to rewrite this RPC stuff. I'm almost wondering if we just do this framing protocol. I wonder how they know how long the greeting is, because it doesn't. I guess these are fixed length things. Final short. Octet. Huh. thing is, stuff like this can, in theory, be done at a protocol level. So you build your own protocol via RPC. I'm sure there's already an MTP, media transfer protocol. Of course. Messages, more frame. More and then body more. I'm not clear though what oh, I see. This is, you can have many more frames before the final frame. Final frame is body, final short, final long, final short. I see. Trying to decide whether we assume framing or not. Muxadoo. I mean, I kind of wish that his protocol was defined so I could understand the differences between there. The fuck? Settings? See, the only thing though, stream identifier. Yeah, so I'm thinking of using this for the base for but like the simplified version that's closer to what Alan was doing here. Let's see, how would that work with the way I was thinking about this? One message per frame. Yep, I'll talk to Alan and see if we can yeah, I think it would satisfy everything I'm looking for. Wait, does this say? Frame definitions. stream identifiers. What I'm looking for is so these are all the types. Variable length sequence. Data frame defines the following flags. Okay, so this is the last. Cool. I think that's all I would need. HTTP, huh? So much for hypertext. Yeah. Trying to think though. Okay. All right. That's it. Sorry to put you through that kind of quiet thinking process. Nobody was here to ask me questions. And there's kind of like design stuff that I was doing in my head, so probably wasn't best for the stream, but we did get our hub working, and so then now the next thing we can do is actually create a daemon, a hub daemon that will then run plugins that presumably connect to the hub to provide methods. And so I believe using these existing implementations in JavaScript and Python and Go, we could create plugins in those different languages and provide functions in those different languages to a client, which can be then also written in any of those languages. So I guess that's the other thing I'm concerned about this, is if it is what do you call it? Yeah, I guess it's the peers on the session, like it is symmetrical. They both speak the same framing and transport thing, I'm hoping. see, session open. Yeah, it looks like either side can open the connection, so. Wait. Accept a stream. Session accept. Session open. Yep. I might even just use this as much as I can to do the rest of duplex, so we don't have to rewrite this, and then we can kind of come back to this lower level stuff and really document the crap out of it. And the reason for that is so that we could actually implement it in other languages more easily, since we will have to do that. All right, cool. Thanks for putting up with me, and see you doing something more interesting on Thursday. See ya.